Welcome to the new topic today on matrices. A matrix is a way of organizing data into rows and columns. The following is an example of a way in which a matrix could be used. So let's take a look at this. A local college is performing Guys and Dolls at its Performing Arts Center. There are both matinee and evening performances each day. The following matrix shows ticket sales for each show. So if we look at this table, basically, this is what a matrix looks like. We have a column for days of the week, a column for number of tickets sold for each matinee, and the number of tickets sold for each evening performance. And all of this data makes up the entries in a matrix. Now, to get into something that will show us a little bit more of what these look like mathematically speaking and how we can work with them mathematically, let's go on to the next page. Um, a matrix is made up of rows and columns, and we use the number of rows and columns to determine the dimensions of the matrix or the order of the matrix. It's the number of rows by the number of columns. So for example, if I were to give you this matrix right here, I'm going to write down this one. And these brackets here are the symbols we use for a matrix. Let's say we have 6, 2, and -1 going in the first row, and then -2, 0, 5. Okay, we have 2 rows, the rows go across, and we have 3 columns. So we say this is a 2 by 3 matrix. All right, and the numbers in the matrix are called entries. So if we want to look at these other matrices and determine the order or dimensions of these matrices, uh, we have 3 rows going across, and 3 columns. So this is a 3 by 3 matrix. This next one, we have 1, 2, 3, 4 rows going across by 2 columns. So it's a 4 by 2 matrix. And this last one, we have 2 columns. I'm sorry, 2 rows, I meant to say. 2 rows going across, and 1, 2, 3, 4 columns. So it's a 2 by 4 matrix. All right, so I think we've got it down pretty much as to what order or dimensions of a matrix are. They mean the same thing. Let's go on to some arithmetic that we can do with matrices. You can add or subtract matrices only if they have the same dimensions. So same number of rows, same number of columns. Now, what we're going to do is perform the indicated operation if possible. If not possible, state the reason. Probably it's most likely if you can't do it, it's because they don't have the same dimensions. So let's add these matrices here. We're going to add the entries in the corresponding position. So these ones are in the same corresponding position, so we're going to add them together to get 2. The 2 and the 5 are in the same corresponding position, so we get 7. Put the answer in the same corresponding position. -3 plus 2 gives us -1. And 1 plus 0 gives us 1. All right, so there are our answers. Okay, so now let's take a look at this one. These particular matrices do have the same dimensions. They're each a 3 by 3. Let's add them together. So again, we're going to add together the matrices I'm sorry, the entries in the same corresponding positions. 7 plus 1 is 8. -3 plus 0 is -3. 2 plus -5 is -3. 0 plus 0 is 0. 8 plus 8 is 16. 1 plus 7 is 8. 8 plus -7 is 1. 6 plus 9 is 15. And -6 plus 6 is 0. So the resulting matrix also has the same order of the 2 matrices that you were adding together. Okay, so let's move on to the next one. Now,
you're being asked to add together a, let's see, this is 3 rows, so a 3 by 2 matrix, and this is a 3 by 3, 3 rows and 3 columns. The dimensions are not the same, so you cannot add them. So we'll say that this cannot be done. Okay? So now let's move on to our next problem, or our next idea, multiplying by a scalar. Now, what we're talking about is multiplying a matrix by a constant. And so I've got this matrix of 1, -3, 6, and 9, -1, 4. And it's all being multiplied by -3, which just basically means you're going to multiply each entry of the matrix by -3. So -3 times 1 is -3, -3 times -3, +9, -3 times 6 is -18, -3 times 9 is -27, -3 times -1 is +3, and -3 times 4 is -12. And so there is your resulting matrix, which again has the same order as the one in which you originally had as the one that you had in your original problem. Okay. Now we can also use variable expressions with matrices. We can say that this particular matrix here, 4, -2, and -3, 10 is equal to A, and 3, 2, 0, -9 is equal to C, and then go ahead and evaluate. And that's exactly what we're going to do. It says evaluate 3A plus 2C. So that means we're going to say 3 times whatever matrix A is, which is 4, -2, and then -3, 10. And we are going to add that to 2 times matrix C, which is 3, 2, and 0, -9. So let's go ahead and do that. We're multiplying each by a scalar, so we'll multiply the entries of the first matrix by 3. So 3 times 4 is 12. 3 times -2 is -6. 3 times -3 is -9. 3 times 10 is 30. Let's move on to the next one. We're multiplying by 2 here. 2 times 3 is 6. 2 times 2 is 4. 2 times 0 is 0. And 2 times -9 is -18. And it's just like our order of operations. We do the multiplication before the addition. That's why we did that first. And now we are left with the matrices, which are both of the same order. So we can now add them together. So we're going to add the corresponding entries. 12 and 6 is 18. -6 and 4 is -2. -9 and 0 is -9. And 30 and -18 is +12. Okay, and so there is our final answer. So that completes our introductory lesson on matrices, and we will see you next time. Thank you.